Hi everyone, thanks for hanging out with me as we answer some data warehouse questions from Info Studies 410 at the University of Wisconsin Flexible Option Program. The first question here is, what does it mean when data warehouse is non-volatile? Provide an example. So non-volatile in terms of data warehouse simply means that something that's been inserted cannot be changed. This is really important, especially when you're talking about financial systems and things like that, but it's very important for any business. It's important because when you input data, you don't want that data to be changed. In the future, you might want to learn some things from that information. You might want to learn how many transactions you had, or what type of card people used, or what type of products you sold. And if that information gets changed somewhere along the way, you won't be able to gather some learnings from your previous data and figure out what you need to change, what you need to change in your business to be more successful. So it's very important in terms of looking at historical data. It's also important in thinking about this example of financial data. It's important for consistency. If you purchased a product from a store and then the store or the bank changed the price of that product and charged you more than you had bought it for, that would be fraudulent, and it would really be a distrust on the terms of the organization. It would not build trust with you as a user or consumer, and it would provide a lot of issues legally as well. So that's why it's important that data in a data warehouse is non-volatile, meaning that it cannot be changed once it's inserted. The second question here is, what is the fact table in a data warehouse? And provide your own examples. And a fact table is a multi-primary key table which contains foreign keys to each of the reference tables in the warehouse. I think of the fact table as like the main table, or maybe the center of it all. And then it has little legs that reach out to the other reference or dimension tables that give you more detail about the different things that it specifies. So the example I provided here is we have a primary fact table of transactions. And in our transactions table, we have the merchant ID, and that might be the store or retailer that the transaction occurred with. We have the user ID, that might be the person that created the transaction. We have the payment method ID, and that would be what they paid with, and what type of card, or if it was an ACH or bank account transaction, all those things. We have a time key to figure out when the person actually paid. Then we have amount and source fields to determine how much their payment was and where their payment originated from. Was it an online payment? Maybe it came from a mobile application, or maybe it came from some other source. So this is a great example of the fact table being in the center, and then the dimension and reference tables being around the outside. Now the merchant ID table, you can see links to a reference or dimension table called merchant, and that has various keys on it: merchant ID and name, and what they're doing business as, and the type of merchant they are. Maybe they're a retail store, a nonprofit organization, a variety of different options available there. Branching over to the right with the user ID, that's a foreign key that links to the primary key in the user column, and we can see there that some of the different references or columns for the user table would be the first name and last name of the user, their address or phone number and email. And then moving down to the bottom left-hand corner, the payment method is a foreign key to the payment methods table, and we can see some columns we have there: payment method ID and the card type and the token for the card, maybe the expiration date or the CVV. And then finally, reaching down to the bottom right, we've got, of course, the time key, which goes out to the time table and has columns that are relating to the time of the transactions. This is a great example of the fact table being in the center and a sort of a snowflake diagram, they call it, and the reference or dimension tables being around the outer edges. The next question is, when do you use OLAP? And provide your own examples. OLAP is really useful when a user needs to answer questions that contain aggregate data from many dimensions or reference tables. And I love the visual examples of OLAP from the textbook and other sources I was reading of a cube and having basically X, Y, and Z coordinates all being different tables. And these are really, really helpful for answering complex questions that might reference multiple tables of aggregate data. So it's really great for a business to get insight, and the example that I provided here will come a little bit more in the next question, but for this question, a really simple example is how many transactions occurred within a given time period, going back to our financial example. And it's really nice because in an OLAP model, you can basically slice that data to incur just a very specific time period that you can look at and determine all the data that occurred within that time period. So it's a really great model to use, especially for users to be able to pull out information they need and provide some insight for businesses. The next question is, what three types of actions do users typically perform when they use OLAP software? Provide examples and circumstances. This was a fun question to answer just because of the way that OLAP works, and I'm a very visual person, and OLAP is a very visual and referential way to retrieve data from a database. So the three actions that users typically perform with OLAP software are slice and dice, drill down, and roll up. And slice and dice is a way of segmenting and omitting data that isn't particularly useful to the user. You can think of this just like when you're chopping fruit or chopping a vegetable. You slice and dice to remove parts that might be rotten or bad or moldy, and hopefully that's not many of your vegetables, but it provides a great visual example of what's actually happening to your data. So you're slicing and dicing away chunks that you don't need, that are too old, or they're really not important as to what you're looking at. They're not applicable to your situation, so you're slicing and dicing, you're removing extra data that you really don't need. And a great example of this would be an outage at a financial institution. And in this case, let's say a financial institution has an outage. They could slice and dice the data to find the affected users and merchants within that time period. They could then use this data to notify the users and merchants that there was an outage and that the users or merchants could attempt to make their payments again. So slicing and dicing is very useful in this circumstance because the institution only wants to notify those users and merchants that were affected. It doesn't necessarily want to notify or get information about other users, merchants, and transactions that were not a part of this particular outage. So slicing and dicing would be very useful for that situation. Drilling down is basically taking the data that you've sliced and diced and making it even smaller. To go back to my analogy of cutting vegetables, you might chop all the bad parts off of a carrot, and then you might drill down and julienne the carrot, so you have some really nice, small, really thin strips. Well, in the same way, the drill down function is very useful for users to gather the specific, detailed information they need. Once they've sliced and segmented their data the way they want it, they can further eliminate extraneous data and focus only on the most relevant results for their situation. In my previous example, what if the company later on learned that the outage only affected a certain card brand? It'd be really important for them to drill down into the data that's already been sliced and diced and figure out which users use that card brand, only notify those users. So it's very useful for getting more specific and detailed information about your information and your data. Lastly is the roll-up function, and the roll-up is actually the opposite of the drill-down function. It actually adds extra data back in for perspective and analytics. So, if you think about a financial company having an outage, that would seem like a really huge, serious problem. But maybe once you drill down, you found out there was only 10 or 15 or 20 affected users. When you look at all the users that made a transaction that day, you might find that that's actually a very small outage. So it's very useful for providing perspective and analytics, and for really determining to the effect of the data that you're looking at, the effect that it had as a whole on the company or business that it's operating under. The fifth question is, what is data mining, and provide examples of different approaches. Now, data mining is using tools to uncover trends, gain new information, and predict the future based on historical information. There's a great piece of software that comes to mind when I think of data mining, and that's a software called Tableau that's based right here in Seattle near where I live. And Tableau is a really great company because they provide a cloud-based software solution that allows you to analyze, query, and display your data in a new way that helps you gain insight from it. And so data mining is really using tools like Tableau to figure out, based on your data, what trends are happening, what information can I learn, turn that into knowledge, and what might happen in the future based on what's happened in the past. So you can use this first to provide some historical perspective. And historical perspective, going back to our financial institution, Historical perspective can be really important because you might find that during a certain time period of the year you had a lower or higher number of transactions than the rest of the year. Well, you can use that historical perspective to help the future of your business be better. And you might use that perspective to communicate to users proactively to make a payment, or maybe communicate to merchants proactively to communicate to users to make a payment. So there are ways that you can use the information and data that you have from the past to improve your business and to uncover trends and to get you information to help your business move forward and do better in the future. So data mining is a really cool occupation. It's actually it's its own job, and it's its own whole suite of software tools now, because companies have so much data and they want to be able to use that and put it to work for their business. The last question here is, listen to the story at that URL, which is an example of a real-life data warehouse. Then research what Amazon.com is doing now for its data warehouse. And research and find examples of other data warehouse and technologies used there, software and hardware. So the story at that URL is very interesting, and I found it pretty fascinating. That when something is ordered online, you've got people sort of running around finding it and throwing it into a box and shipping it off to you. So it's very interesting and a really great analogy for what happens in a data warehouse that's hosted electronically. So Amazon.com right now has this product called Redshift, which is its data warehouse product. Now there's some really cool things about Redshift. They're calling it a fast, fully managed, petabyte-scale data warehouse that makes it simple and cost-effective to analyze all your data using your existing business intelligence tools. It's really neat because with this type of cloud-based SaaS subscription model, companies can start a free trial or sign up, and it's totally subscription-based, and you only pay for what you use. And Amazon's got some really neat things to figure out what you're using, how much performance you need, how much space you need, and some really great things to know how to bill you properly, and so you don't overpay and they don't overcharge. It's a really cool solution, and it's really beneficial for companies because other data warehouse solutions might have upfront costs or setup fees, and a lot of times they're based on tiered flat fees. Another competitor in the data warehouse market in terms of software is a company called Snowflake. They provide what they call a data warehouse that is more flexible, scalable, and easy to use than anything else available. And basically what they've done is redesign certain aspects of a traditional data warehouse to make it more elastic, to make it more scalable, accessible by a larger number of users, and more accessible by people that are doing data mining and that are data scientists. So it's a very cool solution. It's somewhat new as well. It didn't appear to have as many customers as Amazon Redshift, but still is doing some pretty amazing things and revitalizing the way that a data warehouse works and then works for the company or business that purchases it. And the last thing I took a look at were some on-premise solutions, and some companies do opt to use their own hardware to house their data warehouse. And it is very secure, but there's a lot of problems that at least I see with this model in my opinion. First, the hardware can be very costly. You have to do a lot of research, and you have to really know your business well. You have to know where your business is going for the next 5 or 10 years, and you have to also get that approved in the budget to make a huge upfront purchase in hardware. And especially with technology these days, the hardware is likely to to deprecate or age quickly, and then you're basically back to square one, having to purchase new hardware or upgrade your existing server. So it's very expensive and time consuming to purchase and research and maintain. And on top of that, it has to be managed by someone. Someone has to be there to ensure the servers are running well, that the storage is working properly, that the environment is correct, and that usually requires at least one, if not many, IT professionals depending on the size of your company. So having the hardware on site can have some advantages, but mainly appears to just be a very costly option for housing a data warehouse. Those were the questions I had to cover today. I really appreciate your time and hanging out with me as we look through some of these questions about data warehouses and what they're used for, different technologies that are involved.